All right, so it's 6/6, day one. It's split it into 2 days, today and tomorrow. We'll review Friday. We will quiz or test on Monday. Now, so we did push that back. We're just looking at the first 3 examples today. In the warm-up, we looked at arithmetic sequences. We are looking at sequences again today, but a different kind. Arithmetic was we are adding the same thing every time. Today, we are going to be multiplying by the same thing every time. This is called a geometric sequence. So a geometric sequence is going to be when we multiply by the same thing every time. So we're multiplying by the same thing every time. So a couple examples of geometric sequences here. There's a geometric sequence. We are multiplying by the same thing every time. Again, multiplying by the same thing. So it's okay if it's negative. That's fine. Okay, we can have negatives in our sequence. Perfectly okay. We've got 3 examples of geometric sequences here. We already said it's because we multiply by the same thing every time. Tell the person next to you, what are we multiplying by every time? Okay, here we go. Here we go. Raise your hand for the top one. What is our, what are we multiplying by every time here, Tim? 2. We're multiplying the top by 2 every time. Okay. How about our middle one here, Parker? 4. We are multiplying by 4 every time. What about this bottom one here, Izzy? 1/2. 1/2. We are multiplying by 1/2. I know some of us were thinking we're dividing by 2, and that's true. But the question was, what are we multiplying by every time? And what we are multiplying by there is that 1/2. Okay. Abe?
Could it be like you multiply by a negative?
You could multiply by a negative. Yep, and we'll see that later on. Yep, absolutely. So these numbers, we found the common difference during the warm-up, which was in the arithmetic. Now, these numbers are considered the common ratio. So the common ratio is what we are multiplying by every time. And again, it is what we are multiplying by. It's not what we're dividing by. So when we ask for a common ratio, we should never say divide by something. We should always say we're multiplying by, and it just might be a fraction, and that's okay. Any questions on what a common ratio is? Let's say we're unsure of what the common ratio is. These were pretty straightforward. I think we could do these in our head. Well, let's say we're unsure of what the common ratio is. You can always take a number and divide it by the one before it. So if you take a number, divide it by the one before it, that's going to give you that common ratio. 24 divided by 12, gives us that common ratio. Right? 16 divided by 32 is 1/2. So we could do that all the time. If you're ever unsure, take a number, divide it by the one before it, you got your common ratio. Okay? What I want you to do next is I want you to find the next 3 terms for each one. Okay, the next 3 terms for each one of these, please. That last one, I want fractions and not decimals. And fractions, no decimals. Okay, check somebody, see if they got the same thing.
Oh, that's right. Yeah.
And then the last part, 1/2 is 4 points.
All right, here we go. Raise your hand for that top one. What do we have for the top one here? Autumn? Okay, there we go. Good. For the middle one here, Kellen?
Negative 256, negative 1024, negative 4096.
There you go. As we can see, right, it gets big in a hurry for those. Okay. What our last one here, Tim?
1/2, 1/4, 1/8.
There you go. Good. Thank you for getting those right. Third hour got all 3 of them wrong.
How?
They just gave me wrong numbers. I don't know.
I got wrong. 0.
Sometimes you hit a number in wrong, you type one number and it messes up the whole thing. Anyway, so let me point out on the bottom one, if we're dividing by number or multiplying by a fraction every time, all you're doing is you're multiplying the denominator by that number. Okay, regardless of what the numerator is going to stay the same. Okay, so let's say I had some sequence here and I ended on a 7 and my common ratio was to multiply by 1/5. Okay, we don't need to get frustrated and grab the calculator right away. If I'm dividing by 5 or multiplying by 1/5, that's just 7/5. And then it's 7/25. And then it's 7 over 125. You're just multiplying that denominator by what you're dividing by. Okay? It shouldn't be something where we're getting these long decimals. Keep it as fractions. Okay? Yeah.
What if it's like 3/4?
If it's 3/4, same thing. You're going to take that Or you're saying multiplying by 3/4 every time?
Yeah.
That you're gonna wanna use calculator probably, right? But you could multiply the top by 3, the bottom by 4, right? It would work that way. Just a little harder. All right, any questions on these? All right. Good deal. Next thing we want to look at here is just to identify what type of sequence we have. So we've got 3 up here, arithmetic, geometric, or neither are your choices. Talk to the person next to you, which one is which out of these?
Second one is. No, third one is second one. What's the third one? Either.
All right, here we go. Here we go. Number 1, is that arithmetic, geometric, or neither? What am I looking at here? Give me
Arithmetic.
arithmetic. We are adding -4 every time. There you go. How about for number 2? What do we have for 2 here, Audrey? Say it again, sorry. Geometric. Geometric. We are multiplying by 1/8 there. Okay, and feel free to use a calculator to double check when you're checking on it, right? And for 3, Parker, that is neither, right? That is add 4, add 6. That's nothing. Good deal. I want to point out one here because we did have the question earlier about can you have a common ratio that's a negative? And this is what it would look like. It would jump back and forth between positive and negative. Because every time here we're multiplying by a -1/4. Right, so that's should be no problem. We're still just dividing by 4. It's just we're going back and forth between positive and negative. Just be careful on that when you're giving your answers, right? Pay attention to what you ended off with. The next one's going to be positive, then negative, then positive. Right? Just wanted to show you that is a possibility. We will see that in our sequences. All right, any questions so far? Okay. All right, next thing that we have to look at is graphing. We are going to do a little bit of graphing. Okay, a little bit of graphing. It's okay. You'll survive. So here's our sequence. It is a geometric sequence. And we are going to graph the sequence. Now we did this with arithmetic stuff. Okay, we graphed our arithmetic sequences. It was a long time ago, so don't blame me if you forgot. But what we're going to do is the sequence itself, these numbers, these are going to be our y values. Okay, these are going to be our y values. And then our x values are just going to be what number term it is. So it's always, the x's are always going to be 1, 2, 3, 4, 5. Okay, because that's the first term, second term, third term, and so on. So once you know that, right, they gave you the sequence. We know it's always going to be 1, 2, 3, 4, 5. Now we just have to graph those points. Okay, I want you to go ahead and create a graph. I want you to graph those 6 points, please. Take a couple minutes, graph those 6 points. All right, so we've got the graph up here. Hopefully yours looks like this. Hopefully yours is not a straight line. It should not be a straight line. It should be a curve. What type of graph does this look like? What does this look like? Parker? Yeah, it's an exponential graph. It's an exponential graph, right? And that's because we're multiplying by the same thing every time, and that's what exponential did. Was it multiplied by the same thing every time? So in your notes, I want you to write down that a geometric sequence is exponential. So a geometric sequence is exponential. And tomorrow, the second part of 6.6, we'll get into how to change that sequence into an equation. Okay, an exponential equation. We'll learn how to go back and forth there. That's tomorrow, though. But today we see that in the graph, and we know if we keep dividing by 2, we're never going to reach 0, just like the graph is never going to reach 0. Now, on your graph, make sure your dots are not connected. Should not be connected, because I didn't give you an equation to graph. I gave you points to graph. So there's a difference there. Okay, so make that change if you need to. Make a note if you need to. Okay, but they are not connected. This is discrete. I just told you to graph those 6 points. I didn't give you a whole equation. If you're connecting them, what you're saying is there's data in between those. You're saying I could find the 2.5 term, and that's not a thing, right? It's just 1, 2, 3, 4, 5, 6. All right, good deal. Questions on that graph? Okay, and of course, we do see if we were to connect it, it would look just like that exponential, right, with that curve. Okay, we're gonna do one more here. All right, I want you to go ahead and graph that sequence. Those are the y values. Your x values are always 1, 2, 3, 4, 5. So I check with somebody, see if their graph looks like yours, see what they're doing, see if you're on the right track here. All right, as you're finishing up, if we take a look at it, this is what it should look. It's gonna bounce back and forth between above the line and below the line. There's another reason why we can't connect the dots, right? If we connect these, you're gonna have this whole zigzag thing going on, and that means nothing to us. So you still are going to see exponential graphs on here. You're just gonna see two of them, right? We see an exponential up here, and we see an exponential down here. And your numbers are really just bouncing back and forth between the two. Okay, so it still does have that shape. It's just because our common ratio is a negative here, it's going to bounce back and forth between them. So just know this type of graph is okay. Right? Most of them are going to look like this, but if you're going back and forth, it is going to be split like that. One small thing on your graph, make sure whatever you're counting by going up, you're counting by the same amount going down. Right? I can't count by 20s going up and 10s going down. Right? It's got to be the same thing up and down. Side to side can be something completely different than up and down. Okay? But up and down need to be the exact same. Okay, any questions on our geometric sequence? Tomorrow, with the second half, like I said, we're going to create that equation. And then we're also, if you think back to what we did with arithmetic, we're also going to be able to find the 20th term. Or the 10th term or something like that. We're going to have a formula that's going to help us find that. Okay? All right, go ahead.